Hey guys, this is Marcus. I am going to work problem 569. I heard a lot of people have problems with it and got it wrong on the homework, so I figured I would show you guys how to work this guy. Alright, so this was a Thevenin problem. You can kind of see in red where I highlighted what you had to cut out of this circuit. The values in this problem might be different for yours. This is just one of the students that came in and asked for help on this homework problem. So I verified that the answers are right, so let's see what we have to do. So if we try to find VOC, as you can see right here, the big thing that you need to pay attention to is that the only current flowing through this is IX, and IX is pretty easy to find. You can just say IX is going to be equal to that voltage source. Now you can see that the voltage source is kind of pointed downwards in the opposite direction where we assume IX or the current would flow. So we can say IX is going to be that voltage source minus 1 divided by the 2K and the 6K. So then that will just make IX minus 1 over 8 milliamps. Once we find IX, we then know what the dependent voltage source voltage is going to be. So if we say V dependent, that's just going to be equal to 3K times IX, which in this case we found to be minus 1 over 8, and that's going to give us minus 3/8 volts. So to find VOC, there's different things and different ways that you can go about this. I'm just going to do a KVL loop. So we're going to do a KVL loop. And that's going to be across the entire outside. So we're going to have plus 1 volt. Then we're going to have a voltage drop across that 2K. So we'll say 2K. And then the current going through that 2K is going to be IX, which we found to be minus 1/8. And then we're going to have that voltage source, that's going to be minus 3K times IX, which was minus 1K, or minus 1/8 K. And then we're going to have VOC, that's all equal to 0. So then when we simplify for VOC, it's going to be equal to minus 9/8 of a volt. Okay, so that's finding VOC. So the next step is going to be to find I Norton. And to find I Norton, the easiest step, especially with Thevenin circuits like this, is to just do a KCL. Many times when you do I Norton, you can connect I Norton down to ground, as you can see here on the right side, and that usually simplifies your analysis a little bit. So we're just going to write a KCL out. So KCL, we're going to have Vx minus the minus 1 node on the left. That current leaving is going to be divided by the 2K. That's just Ohm's law for the current leaving. Then we're going to have Vx leaving from Vx leaving through the 6K. That's just the current going down. And then we also have I Norton. So that's our KCL. That's kind of our supernode external is what I like to call it. So we're going to write a constraint equation as well, and you'll see some cool stuff pop out. So for the constraint equation, you could write 0 minus Vx is going to be equal to 3K times Ix. That's the constraint equation for the dependent source. We can go ahead and say that this is going to be Vx is going to be equal to minus 3K, and then Ix is just simply going to be Vx over 6K. And if you continue on with this, you'll see that Vx is simply equal to 0. So this is a really cool thing to see, because this means that when we go back to our previous equation, this Vx right here and this Vx right here cancels out. So then simplifying this equation, this is just going to be In, which is going to be equal to minus 1/2 or minus 1/2 milliamps. Okay, so now that we have VOC and I Norton, we can go ahead and find RTH, and RTH is simply going to be VOC divided by I Norton, and so we'll have minus 9/8 divided by minus 1/2. And you can see how the negative signs cancel out because you really can't have a negative resistance usually. So, and if you flip those, you'll see that you'll just end up with 18/8 K, which will end up being, not K, 18K, which will be 2.25 kilo ohms. And that's it. The rest of the problem is fairly easy to solve, so I'm not going to bother going through and adding in the current source and all the rest and finding VO. You should be able to do that. I just wanted to walk you kind of through the dependent source problem, or part of the problem. That tends to be a little harder to figure out. Alright, I hope you guys have a good day.